Hey, this is Mr. Harashi with lesson 1.3, solving equations with the variable on each side. So when you're solving equations, there are certain things that you want to do no matter what type of equation you have. Simple equations, multi-step equations, equations with the variable on each side. The steps here that I have listed for you basically cover almost every single equation that you're going to solve. Here's an example of solving an equation with the variable on each side. So with the variable on each side, whatever the variable is, you'll have that same variable on each side of the equation. For example, 3y plus 45 equals 8y plus 25. You have y on the left side of the equation. You have y on the right side of the equation as well. We won't get into yet having two different variables on each side of the equation. But like we did with our multi-step equations, if you can, you want to simplify either one or both sides of the equation. On the left side of the equation here, 3y plus 45, those are unlike terms. One of the terms has a y in it, the other term is just a number, or it's also referred to as a constant. And then same on the right side. Okay? And then since we have the variable on each side of the equation, we want to try to get the variable to one side of the equation using inverse operations. So regardless of what kind of equation you have, you're always going to use inverse operations to isolate the variable. Okay, so I'm going to work through this first example. It actually doesn't matter what side you get the variable to. Most people or some people like to get the variable to the left side all the time, and that's what I'm going to do. So on the left side, we have 3y. On the right side, we have 8y. So either 8y is being added to 25 or you're adding 25 to 8y. This 8y is positive or it's being added. So the inverse operation is to subtract 8y from each side. That would get the variable to one side of the equation. So I could subtract 8y from the left side, still an equation. Whatever you do to one side, you have to do to the other. And then you subtract 8y from the left side as well. Okay. So 3y minus 8y, basically you're just subtracting 3 minus 8, 3 minus 8, and negative 5. So you have negative 5y. Still have plus 45. And then on the right side of the equation, 8y minus 8y is 0, but you still have 25, and 25 is positive. So it's equal to 25. Now, it's identical to what we did in lesson 1.2, solving multi-step equations. So you use inverse operations. What's being done to the variable is you're first multiplying it by negative 5 and then adding 45. So the inverse operation of adding 45, subtracting 45 from each side of the equation. On the left side, all you'd be left with is negative 5y. On the right side, 25 minus 45, it's negative 20. You need to be proficient with adding and subtracting and multiplying and dividing positive and negative numbers. If you're still having a little bit of trouble with that, just keep practicing and or use a calculator. Okay, and the last thing that's being done to the variable is it's being multiplied by negative 5. So the inverse operation is to divide each side by negative 5. On the right side, negative divided by negative is a positive. I'm running out of room, so I'm going to write the solution over here. Left side, you're just left with 1y or y. And then negative 20 divided by negative 5 is positive 4. And as always, I can check my solution, go back to the original equation, and substitute 4 in for y on both sides of the equation. I'm just going to do some things orally here. So 3 times 4, 12, plus 45 is 57. Just going to write that on the left side so I can keep track of things. On the right side, 8 times y, so 8 times 4 is 32, plus 25 is 57. So both sides of the equation equal the exact same thing. 4 does check. Okay, on example 2, now I have the variable on each side of the equation as well. M's on the left side of the equation. M is on the right side of the equation as well. But here's what we can do, and here's what you should notice. On the right side of the equation, you have 2m plus m. Those are on the same side of the equation. So you just do whatever the operation tells you. 2m plus m. I don't want to try to use inverse operations yet. That's just to get the variable to one side of the equation. Here's what I say. Okay, if you have the same variable on the same side of the equation, just use whatever operation or same operation, 2m plus m. If you have the variable on opposite sides of the equation, that's when you want to use opposite operations or inverse operations. Okay, so on the right side, we can simplify. 2m plus m are like terms. If you just have m, even though there's no number written in front of it, there's an implied 1. M is the same as 1m. So I'm adding 2m plus 1m, and that's 3m. You still have the minus 2. And then the left side, at least right now, stays the same, 5m plus 6. So now, since we simplified what we can on each side of the equation, we want to get the variable to one side of the equation. Okay, on the right side, you're adding 3m to negative 2. That's the same as subtracting 2 from 3m. The 3m is positive, even though there's no sign in front of it. So the inverse operation is to subtract 3m from each side of the equation. On the left side, 5m minus 3m. 5 minus 3 is 2, so that's 2m plus 6 is equal to, on the right side, negative 2. And then again from here, you use inverse operations in order to isolate the variable. M is being multiplied by 2, and then you add 6. So the first inverse operation is to subtract 6 from each side. 2m is equal to negative 2 minus 6 is negative 8. And then we can divide each side by 2. Negative 8 divided by 2, m is equal to negative 4. If you substitute that back in, 5 times negative 4 is negative 20, plus 6 is positive 14. On the right side, if you substitute in negative 4, actually it's negative 14 on the left. I said 5 times negative 4 is negative 20, plus 6 is negative 14. On the right side, 2 times negative 4 is negative 8, minus 2. So negative 8 minus 2 is negative 10, and then plus negative 4. So negative 10 plus negative 4 is same as negative 10 minus 4, negative 14. So negative 4 does check. Okay, and then on example 3, here's what we need to do. Simplify. By simplifying each side of the equation, since we have the variable on each side of the equation, which is t, we would actually distribute. I'm going to write my solution up here for problem number 3. So we distribute the 8 to the 2t and the 8 to the negative 3. That's what's inside the parentheses here. This negative t is not inside the parentheses, so you would not distribute the 8 to the negative t. So 8 times 2t is 16t. 8 times negative 3 is negative 24. We always want to pay close attention to detail, make sure that we have every single part correct, and then we still have the minus t. If you just mess up on one part of the equation, it's going to goof you up for the rest of the equation as well. Is equal to, on the right side, I could distribute the 3 to the 3t and the positive 2. So 3 times 3t is 9t. 3 times 2 is positive 6. So we have the variable on each side of the equation, but on the left side of the equation, we can simplify. 16t minus t, kind of like on the last example, this minus t is the same as minus 1t. You don't have to write it in there, but for some people it might help. So before we get the variable to one side of the equation, simplify the left side. 16t minus t, 16 minus 1 is 15, we saw the t, minus 24 is equal to 9t plus 6. So now we get the variable to one side of the equation. What I usually do is get the variable to the left side. You'll see, or you should see if you're doing everything correctly, that if you get the variable to the right side of the equation, you would get the same solution. So I'm only subtracting the 9t from the 15t. I'm writing things in the correct place. I don't want to write the minus 9t underneath the negative 24 because they're unlike terms. 15t minus 9t, 6t, minus 24 is equal to 9t plus 6. Sorry, 9t minus 9t is 0. Subtract a 9t from each side, so that's just 6. Okay. Now we use inverse operations to isolate the variable. First, add 24 to each side to get rid of the negative or minus 24. You have 6t is equal to 6 plus 24, 30. And then I can divide each side by 6. So t is equal to 5. If you check your solution here back in the original equation, here's what you could do. Everything inside parentheses first. So I'm using PEMDAS. 2 times 5, 10 minus 3, 7 times 8 is 56. And then minus t, so 56 minus 5, 51. On the right side, 3 times 5 is 15. 15 times 2, 15 plus 2, 17. And then 17 times 3, 51. So 5 does check.